What is inverse variation? Let's consider the amount of soft drink each person gets. When 1,500 ml of soft drink is shared equally among different number of people. Let x be the number of people and y be the amount of soft drink each person gets. When x is 1, the amount of soft drink each person gets will be 1,500 ml. Since there's one person only. When x is 2, the amount of soft drink each person gets will be 1,500 over 2. That will be 750. When x is 3, y will be 1,500 over 3. That is 500. When x is 4, y is 1,500 over 4. That is 375. When x is 5, y will be 1,500 over 5. That is 300. We can use an equation to connect x and y. Say, the amount of soft drink each person gets. Y is equal to the total amount of soft drink, 1,500, over the number of people, x. So y is equal to a constant, 1,500 over x. If let's say for any two quantities they satisfy this kind of equation, y equals a constant over x, then we can say x and y, they are in inverse variation. Or if we know x and y, they are in inverse variation, then we can also say y is equal to a constant over x. So in general, if y varies inversely as x, or we can say y is inversely proportional to x, then we have y is equal to a constant k over x. Or if we move x to the left hand side, we have the product of x and y is equal to a constant k, where k is a non-zero constant. Why k is a non-zero? Let's think, if k is 0, what happens? If k is 0, y is equal to 0 over x, which is 0. So y is 0 no matter what the value of x is. This is not inverse variation because x and y must be connected somehow. So k is not equal to 0. K is called the variation constant. In symbols, we write this to represent y varies inversely as x. In the previous section, we know that this means y varies directly as 1 over x, right? But why we can use this to represent inverse variation? Let's have a look on the right hand side. The second remark. If y varies directly as 1 over x, that means y is equal to a constant k times 1 over x. And that means y is equal to k over x. This is exactly the inverse variation. So that's why we can use the whole thing to represent inverse variation. And let's have a look on the first remark. In the direct variation, y varies directly as x. That means y is equal to a constant times x, right? If we move x to the left hand side, we have y over x is equal to a constant. But in inverse variation, let's say y varies inversely as x, then we have y is equal to a constant over x. If we move x to the left hand side, we have x times y is equal to a constant. We can compare these two cases. In direct variation, y over x is equal to a constant, but in inverse variation, x times y is constant.